Welcome everyone to another episode of Vision Basic. In this video I'm going to do something different. Since I'm working on improvements to the Vision Basic software at the moment, I wanted to find a way to put out a helpful video for my audience, but without a huge investment of my time. So I'm going to share a tool from the past, my past, that I've used multiple times. And this tool is especially great for programmers of regular C64 BASIC, although it can be used for Vision Basic programs as well. Let's say that you are writing a program that needs to poke a bunch of data to memory. Typically, you'll have a bunch of data statements full of data, and you'll read that data byte by byte and poke it to memory. This is a very slow process, as we all know. You can also elect to simply load the data into memory, and this isn't really all that hard, but you will typically only want that data to be loaded a single time, so you'll have to set up some kind of method to verify that the data is already in memory. But I'm the kind of person who likes my programs, where possible, to be comprised of a single all-in-one file that you can simply load and run. Vision Basic has an advantage over regular BASIC because you not only have the extra speed, but you can simply start typing bytes of data and have them executed within your programs instead of those bytes having to be poked to memory. And if that data needs to be relocated elsewhere before execution, you can simply use the copy command to copy that data to its new spot at blinding speed. But let's say that you have a sprite file on disk and you really don't want to go through the effort of converting that file into data statements, so that you can go with the all-in-one approach I speak of. But let's also say that you don't want those, say, 57 sprite shapes to take forever being poked into memory. Now, I have seen a couple of interesting but somewhat convoluted solutions to this proposed in a couple of videos out there, but I'd like to propose something simpler. A solution called Print Poker. Let's jump back to the year 1985, shall we? Specifically, the month of November 1985. Like me, you might have purchased the latest issue of Compute magazine, or had it delivered to your mailbox. Inside this magazine is where we will find our hidden gem, called Print Poker, on page 125 of the magazine. Well, okay, the program listing itself is on page 126. Now, I could read this article word for word, or we could cut to the chase. The program listed in this article essentially takes your memory resident data. Yes, you'll have to first load it into memory or poke it there, and it churns out a program full of print statements that effectively print all of that data of yours to memory, as opposed to you having to place that data into data statements, creating a for next loop and poking it all into memory yourself. Print Poker creates this program by generating lines of code on the screen and filling the keyboard buffer with return characters, and then exiting the program so that those lines can become a part of the Print Poker program itself. Say that 3 times fast, or 5 times fast, whichever one you want to do. Print Poker ensures that it gets executed again so that it can resume the process of generating more lines if necessary. Finally, it spits out a bunch of blank line numbers and fills the keyboard buffer again with return characters, and this effectively erases the Print Poker program itself. What you are left with is a program that will print all of your data to memory. All you need to do is add your own code to it and save that puppy to disk. Actually, if you type the program as listed, you will find that it doesn't completely wipe out the entire Print Poker program. We find out in the January issue of the following year that there was a bug in the program, and they listed the fix for it on page 87 of that January 1986 issue. I apparently did not get the memo because the version I have on disk still contains this bug. But do not fear. I found a copy online that you can download, if you wish, thanks to archive.org and the Hamilton Commodore user group, which posted a disk image on the site. Oddly enough, most of the files on the disk image appear to be corrupt. But miraculously, the Print Poker program on it still appears to function. And this version appears to be the patched version as well. I don't plan to host a copy of this program on my own website, so hopefully the file stays intact for the unforeseen future. I'll post links to the magazines and the disk image in the description. Anyhow, let's see this program in action. You'll need to have your data already poked or loaded to memory before running the Print Poker program. So I've previously loaded some sprite shapes into memory starting at location 49152. There are about 52 shapes. They are from the Herald game, and I had to relocate them from their original location for the purpose of this video. I also have Print Poker loaded up and ready to run. Except that as I was preparing this video, I discovered that there were still some bugs in the program. For the life of me, I cannot understand how this thing made it to print. My goal was to create a quick video, and then I end up having to debug someone else's program. And it wasn't exactly easy to find the bugs either. So if you download the program, you might want to make the following changes. Here there was redundant code at the start of line 6130. Because as you can see here, you have S1 equals peak S, and then right after that you have it again. And furthermore, that last byte will never be included without the following changes. So, first of all, let's get rid of the redundancy. And right here, this is preventing us from having that last byte output. And press return. Next, we're going to list 60220. Here we need to set the reverse flag at the end of this line to 0 so that it will be set properly at the onset of the next 256 byte page to be printed. And that may not make a lot of sense to everybody, but hey, this is what I discovered. Here's the reverse flag, and we are going to set it to 0. Oops, never mind. Need to put equal in there. Nope, equal 0. R is the variable for the reverse flag. And finally, 60240, we have an unnecessary space being printed into the data stream, so we need to make the following changes. And again, I'm kind of explaining things, but not. You would have to really examine the program to understand what I'm talking about, so just take my word for it. The codes, as the lines are being drawn to the screen, actually, much of what is being drawn to the screen character-wise is actually poked to the screen, believe it or not. So, that's what these pokes are for. Right here, we're poking a quote character followed by a semicolon. So, these are being poked to the screen, and because we had a, go back and change it quickly out, I'm not going to make it permanent, but we had a +1 here, essentially that at position PS, I think there was a space, and it was being kind of included in the line, and no, we do not need that space, nor do we want it. So anyways, I think I already pressed return, so we're good. Okay, and hopefully that covers everything, but if anyone else with sharper eyes can spot other issues in the program, please let me know in the comments. Interestingly enough, I think the bugs will not rear their ugly heads in many situations, so my specific example for this video helped to shed some light on these creepy crawlies. Alright, so with all that out of the way, let's go ahead and finally run it. First, it asks for a starting address, so our data starts at 49152. And now we are being asked for the ending address. In this case, it's 52481. And we're going to pick a starting line number, 500 in this case, and a line increment. Since we have a lot of data, we're just going to go with 1, why not? And we want this to self-destruct. Kaboom! And you'll see that it started running. You'll notice that this is a particularly slow process, and you won't be able to compile this program with Blitz in order to make it faster. I suppose a program could be written that does the same thing as what you see here, but has everything output to disk. We're going to have to put things into warp mode here for the sake of time, otherwise this will be a very long and drawn out video, so here we go, warp mode, Alt-W. And it should get to about line 600 or so. So just bear with it. Be mesmerized by the characters being drawn and printed to the screen. It's also drawing variables and whatnot. Setting some variables so that I can jump back into the program. Actually, it didn't occur to me that it was doing one line at a time. Honestly, I thought it did multiple lines, but in this case here, you can see that it did multiple lines. You know, print the numbers to the screen, fill the keyboard buffer with return characters, and then boom, 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 boom. This all deletes those lines. And then here, variables are like 0, 0, 0, 0. I don't know. That's because it finished. Okay, so let's list our newly formed program. Now remember, this Print Poker created, it's like a self-modifying program. It created all this code from within itself. So here you go. And this is our sprite data converted to a bunch of print statements. Some of you might be wondering how a program can print data to memory instead of the screen. Well, it all has to do with poking certain values into location 648 first. And you can see that right here, and here, and here, and further up the program. This register represents the high byte of the memory location you wish to print data to. When it comes to the low byte, you just have to cursor down and write the appropriate number to help line things up for that low byte, if you were to try to do this yourself. This isn't exactly something for the complete novice to toy around with. It's very easy to crash your computer if you aren't careful. In the end, you'll want to restore things back to the normal text screen, otherwise you won't be able to see what you're typing. Anyhow, if you are a novice, you don't have to worry about any of this because Print Poker takes care of the technical side of things for you. You won't have to toy around with location 648 yourself. The variable P1 in line 600 here is a copy of the original screen location, which has a high byte of 4. You'll see reverse on and off characters sprinkled throughout the print statements in the resulting program. This is how values greater than 127 get printed in memory, since print and poke codes are often not the same values. If you look at the first line of the program, you'll see how it handles the printing of quotation marks. So let's list that, 500. When you print the quote character to memory, it turns on quote mode, and that'll end up outputting special characters to memory instead of utilizing them, like the aforementioned reverse on and off characters. So the variable $, handles this issue in an effective manner by printing the quote character twice in sequence and then deleting one of them. This keeps quote mode at bay. If for some reason you later wish to move your data to a new location, you can carefully adjust the values being poked into register 648. You'll have to locate all of the lines in the program that poke at this register. For example, if you wish to move your data higher in memory by 1024 bytes, you'll just add a value of 4 to every value being poked into that register. If you need to shift things by a value that isn't divisible by 256, you'll probably just want to let Print Poker create a whole new program for you. So for example here, if, going back to what I said earlier, if you want to move things higher up in memory, like say you notice how this says 205, you want to move it by 1K, you'll add 4 to it, so it becomes 209, and then you'll have to add 4. You'll just go up through the whole program and just keep adding 4 plus 4 plus 4, you know, adjusting all of these. Okay, before running the program, let's first wipe out the resident sprite shapes. We're just going to wipe that whole space clean, and the variable p will naturally contain a 0, so we're just using it since it's faster than putting an actual 0 in there. And voila. And I'm going to add some lines to the program. 10 $TI equals 1, 2, 3, 4, 5, 6 zeros, and 610 print CHR $147. This is the clear code. We're going to print out the time, see how long it takes to print this puppy. And now let's run the program and see how long it takes to print 3,330 bytes of data to memory, as opposed to however long it takes to read and poke all that data there. That took all of about 2 seconds. If we compile this program with Blitz or Vision Basic, it will get us down to about 1.5 seconds. Conversely, if we had used data statements instead, my test suggests that it would have taken more than 22 seconds to read and poke all of that data into memory. And it would have potentially cost us more than an additional 7,000 bytes of RAM for our program. Now let's go ahead and verify that all of the data was printed to memory properly as we had previously wiped it out. I'm pretty sure we're good, but it always pays to make sure. So verify, and then the program is sprites.mob. And as you can see, the program works as it should. I recommend always verifying the data if you create programs with Print Poker. Print Poker. I'm going to dream about this thing. If you're wanting to take a data file from disk like I have and use Print Poker to incorporate it in your program, you'll need to know where the data starts and ends. You can use a simple program like the following, which I'm going to copy and print here, to fetch the start and end locations. And the problem is we did not delete we need to delete the program first, the part that prints the data. So, and I'll just run it just to show you how it works. And it gets the start, and then it reads the file byte by byte, and it can take a while. So let's just warp it here. Boom. Okay. And as you can see, we have both the starting and ending locations of our data. Just make sure to change the file name in line 20 to the name of your file, and make sure to leave the "P, R" in there. "P, R." If the file you specify doesn't exist, things will end abruptly and the two addresses will likely be the same value. Anyhow, I hope you find this program useful, and I hope, sincerely, that I found all the bugs for you. Like I said, I think the program might work fine without the changes I made, but then I do think it has a tendency not to include that last byte of data that you wish to print poke. It's a great little program for helping you to combine a program and an external disk file into a single program, and it's not a convoluted solution either. You'll just need to use Print Poker first before creating the program that needs to use that data. Or for existing programs, you can append the output of Print Poker to your programs using the following basic code that I wrote. Yes, folks, Dennis comes to the rescue with another program for you. And voila. This will combine two basic programs together, but it has no safety measures in place, so make sure to type it in with caution. In line 10, you will type in the name of your original game or program, and in line 20, you will type in the name of the program created by Print Poker. And in line 30, you will type in the name of the combined file to be created. Make sure that the starting line number of program 2 is greater than the ending line number of program 1. Otherwise, it'll be quite interesting when you try to list the program. Please type in everything carefully. I'll place the code for this program in the description. We're going to have a very long description, I think. Use at your own risk, of course. Cue evil laughter. Once the combined program has been created, load it into the basic editor and then save it back to disk. The combined program on disk will not have the basic lines linked properly, but when you save it back to disk, the program lines should be linked properly. Actually, the linking happens right after loading, so you can also just start adding to the program if you'd like, and then save over the combined program on disk. And if you're not familiar with line linking, just do a quick research on it. Essentially, in memory, there, as these lines are stored in memory, there's 2 bytes that will point to the next line of memory, and 2 bytes for the actual line number. When you first load a basic program in memory, it will attempt to correct any issues with the line linking those addresses, because you might be copying a program from, say, like a pet computer, pet program, and porting it over to the Commodore 64, and the addresses will not be linked properly. They won't line up. So yeah, that's how it works. That's a simple explanation. The article for Print Poker mentions a couple important details that you'll need to keep in mind. First, you likely will not be able to print data to the last 256 bytes of basic memory, which runs from 40,704. I'll type that for you, 40704. They actually have that wrong in the article. The article they actually have that for some reason. But no, it's that. And then that last byte is, of course, 40959. So that range there, they're saying that you won't be able to print poke to that address range, and they recommend that you just poke the data there yourself. So that's a limitation. Also, if you're going to write data into basic memory, you'll want to drop the top of basic storage pointers down to protect your data. This involves poking the appropriate values into locations 52 and 56 and performing the CLR command. So a lot of times you'll see in programs, you'll see 10 poke 52 48 poke 56 48 CLR. That just means that 48 times 256, hold on. That just means that they're trying to drop the top of basic memory down to location 12288, and likely for the purpose of placing sprite shapes there or something like that. Again, that's not like something for a novice, but it's not really that difficult to figure out how it works. You can also poke to locations. Oh wait, sorry. Associate 52. I apologize. Somebody might try to do that, and they're like, "Why is my program crashing?" Sorry. You can also poke to locations 53 and 55, but that's not really necessary because they contain zeros, and there's really not a point in messing with those two. Alright, I've got a couple more things to say here before I go. You might have noticed that I typically start my videos out with what I call a screensaver of sorts. These programs don't actually function as screensavers, since they don't really kick in during inactivity on a C64, but they do remind me of screensavers, so that's why I call them screensavers. If any of you would like to send one of your own creations my way, a screensaver of sorts, just contact me using the contact page of my website, visionbasic.net. If it fits the mold, I'll consider using it at the beginning of a future video. If you do submit one, you're giving me permission to display and share it without compensation. I will, of course, give you credit in the video. I won't accept anything that makes sound, or anything profane or offensive, or anything containing recognizable characters and such, like Mario or, things like that. So I just want something visually interesting that people can watch while I talk at the beginning of my videos. That's the purpose of these programs at the beginning of my videos, just to keep you entertained while I blabber on. Staring at a C64 startup screen for a few minutes is kind of boring in my opinion, so yeah, that's why I do it. If you were ever wondering anyways. But here I'm just giving you a chance to get to see your own creations on the big screen of YouTube. So, if any of you are so inclined, or, these are simple little programs that you can create, as long as it's interesting, hopefully impressive. I just thought it would be kind of cool to get you all engaged in this, in some way or shape or form. Now, the screensaver needs to be written in BASIC or Vision Basic so that the source code can be looked at by others in case I put the file on a disk image for that particular video. Of course, Vision Basic allows machine language instructions in the code, so that's perfectly fine too. I don't know, I think that's the gist of my rules here for this. So, there you go. I also need to mention that we're nearing the end of the game programming contest that we started back in, I think, January. So make sure to enter by August 31st. Visit visionbasic.fun for further details. And I have an update on the improvements I'm trying to make to Vision Basic. If you have a Commodore 128 computer, Vision Basic will now enable 2 MHz mode during compile time, which pretty much doubles the compile speed for you. The screen will be blank during the compile process though. Otherwise, the speed boost simply can't happen. That's just the major caveat there. So that's the compromise I had to make. It's important to note that the speed boost will be happening in C64 mode on the Commodore 128. I also just have to put it out there that I don't plan to create a version of Vision Basic specifically for the Commodore 128 anytime soon. With what little time I have, I'd rather focus on the C64 version until I'm pretty much done improving it. And just totally done with it. And then I'll look at, the possibility of, ports and other things. So there's just no point in trying to make multiple versions, especially with what little time I have, and then trying to, improve each one, at the same time. If I make a change to one, then I got to go make it to the other. There's no way to just have this central program that's going to run on all of them and make changes and whatnot. So, yeah, that's the main reason why I'm not doing any kind of ports at this time, because it just doesn't make sense. Before starting work on this video, I was spending way too much of my time hunting down a couple nasty bugs in the software that were introduced when I made some fundamental changes to help improve the compile times. On the positive side, I found the bugs and squashed them. Regardless, crashes were happening, and finding the bugs was like looking for a needle in a haystack of code. Anyhow, I have another quote-unquote fundamental change to make in the software in the upcoming days, so let's hope that things go smoother for this next step. Finally, I'm going to share another YouTube channel with you. The channel is called Retro Old Guy. He recently demonstrated the speed of Vision Basic in a quick sort demo. He's got some pretty cool videos, so please check out his channel and subscribe to it if you like what you see. I'll post a link to this recent video of his in the description. Let's help keep this C64 community alive and kicking. Alright, so that wraps things up for this video. Again, I'll be tinkering in the meantime, so I don't know when I'll have another video out, but I will try to keep them coming. Please subscribe so that you'll be able to stay in the loop. As usual, I thank you all for watching my video. I really do. Please like, please share, and definitely subscribe for more similar content. and make sure to visit visionbasic.net.